Hello and welcome to my YouTube channel PSpice Tips. Today I'm going to show how it is possible to do or to simulate temperature analysis in PSpice. For that I have here this example. I have just DC voltage and then I have 4 different diodes. Well, it is the same diode, but it has different temperature parameters. I will afterwards explain what it means. So the first question is, okay, how can I simulate a temperature analysis? Just look here in the simulation settings. I'm going to make a DC sweep because I'm going to vary the DC source from 400 millivolts to 900 millivolts with this step. And I'm going to analyze the forward current in my diode. So I want to analyze how the forward current is going to vary, taking into account the temperature, the ambient temperature. I'm going to analyze. So I'm going to run the simulation in for 125 degrees. It is also possible to make a variation of temperature. For example, to say for 25, 100, 125, 150. So you can make a list. And just consider that in options, in general, the nominal temperature is 27 degrees. It means that the ambient temperature per default is 27 degrees. Well, once it is defined, the kind of simulation, I'm going to show what means or which parameters you can use in each component. And here you have a summary. There are 4 parameters to be used with or that can be used to define the PSpice model. It is T measured, and then you have T absolute, T relative to global, and T relative local. T measured, it means at which temperature you extracted the parameter values that define the PSpice models. For example, in this case, if I just click on it and just say edit PSpice model, we can see that the measured is equal to 27 degrees. It means that these parameters, these values, were extracted or were generated for 27 degrees. If you take your datasheet and you extract these values for the curves of 100 degrees, for example, then you should put here, or you must put here, 100 degrees. Well, once I have said this, if you come here to the other 3 parameters that you can use together with the measure, you have the absolute. It means that when you simulate, it doesn't matter the ambient temperature you have, that such component is going to be always to the same temperature. So if I come here again, for example, to this component, we can see that the T absolute is 20. It means, okay, the ambient temperature in which I'm doing the simulation, 100 degrees, for example, this diode doesn't matter. This diode, the temperature of this diode is going to be always 20 degrees. You can also then say, okay, relative to global. For example, just imagine this one. We are doing a simulation here for a temperature of 125. Just imagine that the relative global value for this component is, let's say, minus 10. It means that the temperature, the ambient temperature for this diode is going to be 125 minus 10, 115 degrees. Okay? And relative to local, it means that the temperature of a component is taken into account related to another component electronic. So it is not so really used. That's why I'm going to show an example with these 2 ones. And here you can see we have, for example, this one. I'm going also to show how it is defined. In this case, for example, the T measure is 120. It means that these values were extracted for 120 degrees, and relative global minus 10, it means that the ambient temperature for this component is going to be the temperature at which I'm doing the simulation minus 10. So once I have explained this, I simulate, and you can see the forward current through the diodes taking into account the voltage. You can see, for example, that the nominal one is this one, that one where the absolute temperature is 20 is this one, and we are speaking about analysis of 125 degrees. That's the analysis we are doing. So the most important thing here is to understand which kind of temperature analysis you can do, and afterwards also to consider how to use such values, such parameters with a PSpice model. If you want to know more information, if you open the PSpice component reference, you can look for the equations that are defining the how the simulator is calculating in the background the new values for the different parameters. And you can see the 10 ohm, it is the value well in the options or the T measured, and T is the value you are doing the simulation. Okay, so in this way the new parameters values are taken into account. I hope it helps. It helps you to understand how to do a temperature analysis and how you should consider the different parameters you could use in a temperature analysis. I hope it helps, and we hear each other in new or coming videos. Bye bye.